If you were to walk into any second grade classroom in America and ask, hey, does anybody in here like math? Just about every hand would go up. It's true. Some kids would even be leaping out of their chairs with enthusiasm. Well, my hand is still up. Given my age, gender, economic background, that makes me something of an anomaly. In fact, mathematical achievement in this country is in somewhat of a crisis. In addition to our disappointing international rankings that we hear about so often, a recent article in EdWeek magazine points out that even our success stories have setbacks. I'm eager to point out that the situation is not quite as dire as we might think, and that our elite mathematicians are not quite as homogeneous as this photo suggests. In fact, our international math Olympiad team, yes, that's a thing, won first place last year for the first time in over 20 years. Congratulations. We are so proud of you. Here's a photo from the award ceremony. 7 elite mathematicians carefully selected from high schools across the country, flanked by their 2 coaches. Since mathematics is the foundation for so many aspects of science, technology, engineering, you might say that these young, smiling men represent the face of our future. I'd say it looks pretty good, but humor me for a second and imagine with me. Imagine if our set of promising young mathematicians represented the same diversity of experience, culture, race, gender, style, personality that is intrinsic to the very core of American ingenuity. What faces do we still not need to see? What voices are not being heard? What perspectives are not being considered? I wonder how our future potential would change if our group of top-performing math students looked more like this bunch. So this is a young theater group and not a math team, but I love the way they look. If I can imagine that each of them has superior knowledge of higher mathematics, then suddenly my vision for the future gets all sparkly around the edges. I can imagine innovations that dance and play, that fly and sing, that break boundaries and deliver hope. So how can we do this? Let's start by going back to the room full of second graders. Here's a picture of me with my family when I was in second grade. For the Catholics in the audience, you will recognize this as a pivotal moment in my young life. A rite of passage, the first Holy Communion. My family was not unlike many American families. My mother worked full-time. My father struggled to hold a job. My grandparents were Army vets. Money was tight. We rented an apartment in the city. Food stamps and bread lines were occasional blessings. Trash day was treasure day. New meant new to me, and stress frequently manifested itself as abuse or neglect. I say this not to evoke sympathy, but rather to illustrate that my middle American urban upbringing was pretty typical. Some have it better, some have it worse, but most, like me, right in the middle. So on this day, amidst the rituals and prayers, while surrounded by family, friends, and abundant blessings, I received my first rosary, my first Bible, a crucifix, and this. You see, my mother was an accidental computer scientist, having chosen a math degree as a result of a misunderstanding and a career in programming by luck of a chance encounter. She doesn't remember this particular gift, but it is one of the most vibrant memories of my youth. And only one of several that was part of an environment that allowed me to interact with math in a playful, creative, and self-expressive way. It is because of these interactions that I believe I managed to escape the fate of so many others, the dreaded math anxiety. As I see it, math anxiety is a fear of looking stupid. It's a belief that I'm not a math person. My brain doesn't work that way. I just don't understand this stuff, and if you ask me about it, I might look stupid. New challenges, success of others, negative feedback. All of these things make me feel small, inferior. They really want you to think I'm smart, so let's avoid math, please. My palms are sweating just thinking about it. Unfortunately, math anxiety is contagious. Plenty of research has shown how math anxiety in a parent or a teacher correlates to poor performance in the children that they interact with. Psychologist Carol Dweck would say that math anxiety is just a manifestation of a fixed mindset, and the antidote is to develop a growth mindset. According to Dweck, if you have a fixed mindset, you believe that intelligence is fixed or static. This leads to a desire to look smart, despite the fact that you don't feel smart, and therefore a tendency to avoid challenges, to give up easily, see effort as fruitless, ignore useful feedback, feel threatened by the success of others. Does that sound familiar? On the other hand, Dweck says that people with a growth mindset believe that intelligence can be developed. This leads to a desire to learn, and therefore a tendency to embrace challenges, persist in the face of setbacks, see effort as the path to mastery, learn from criticism, and find lessons and inspiration in the success of others. As a result, you can reach ever higher levels of achievement, and you will have a greater sense of free will and control of your own destiny. The secret to developing a growth mindset is to embrace the transformative power of difficulty, challenge, failure. New research is showing us that challenge is more beneficial than repetitive practice, and that trying to solve a problem before being shown the solution leads to better learning and longer retention, even when your attempt is wrong. As Joe Bowler of ucube.org would say, mistakes grow your brain. The problem with this idea is that it's a really tough sell, especially when we have for so long fostered a classroom environment that views mistakes as failure and lecture practice routines as essential. We cannot simply take this research and say that F now stands for fantastic. You should be so proud of all the mistakes that you made here. What we need is a paradigm shift. So let's borrow one of the exercises on this worksheet. 25 times 18. Go ahead, give it a try. If you have pencil and paper, feel free to use it, or just work with the numbers in your head. When you have an answer, stick your thumb up so that I can see you're ready. Okay, in my class, I might wait for most thumbs to go up and then ask, does anybody have an answer that you'd like to share? Yes? 450? Okay. Did anybody get anything else? 240. Okay. Anything else? No? Okay. Who can defend one of these two answers? Explain what you did and why you believe that answer is right. Without a doubt, someone in the room will say, well, first I stacked 25 on top of 18. Then 5 times 8 is 40, so I wrote down the 0 and carried the 4. Then 2 times 8 is 16, plus 4 is 20, so I wrote another 0. 5 times 1 is 5, 2 times 1 is 2. When I add it all up, the answer is 450. Ah, the traditional algorithm. Why do I love and hate you so? So smooth and beautiful, but not without a healthy dose of prayer and pixie dust. Okay, but now we got that out of our system. Let the fun begin. Did anybody do it a different way? Here's where I can really tell if I'm in a room full of 8-year-olds or 16-year-olds. At this point, my second grader's hand will shoot up while the 10th grader will stare back at me. Huh? There is no other way. Oh. Well, I thought that 25 times 18 is really just 25 18s. I know that 100 18s is 1800, so half of that would be 900, which is the same as 50 18s. And half again would be the same as 25 18s, or 450. That's no traditional algorithm, but to me, the argument is far more convincing. If I didn't have conviction behind 450 before, I do now. But 8-year-olds are not so easily impressed. Oh, I counted 18 25s instead. 4 25s makes 100. So 8 25s is another 100, then 12 25s, then 16 25s, that's the same as 400. 2 more is 50, so 18 25s is 450. If you don't stop them, they will outfox you for hours. So I need to put an end to this part and move to the best part. Can someone explain where the 240 came from? Well, I thought that 25 is really just 20 and 5. And 18 is really just 10 and 8. So I did 20 and 5 times 10 and 8, and I got 240. This is so lovely, so sensible, so elegant, and so wrong. But why? This is the mistake I've been waiting for all day. It deserves a celebration and an exploration. What is 25 times 18 exactly? Isn't it 18 items reproduced 25 times and then counted? This is a daunting task until you start to lay some structure over the top. And because of our useful base 10 number system, groups of 10 help us to see that there are indeed 20 10s to be counted here. And there are also 5 8s. The reason why that last method seems so sensible is because it was true, or at least partly true. There's still a bunch of dots that need to be counted, namely 5 more 10s and 20 more 8s. Through this exploration, we've achieved 2 bold breakthroughs: a justification for the traditional algorithm, and a model that extends indefinitely. You see, 5 times 8 is 40. 20 times 8 is 160. Then 5 times 10 is 50, and 20 times 10 is 200. The traditional algorithm is simply mimicking these steps, but condensing and making use of shorthand, which becomes invaluable when exercises get longer and a calculator is not handy. But even more importantly, we now have a model that can be smoothed out a little and used for understanding a plethora of multiplication problems. For example, take 3.5 times 8 1/3. Before you knew this model, you might have been tempted to approach the problem like this. Take the big 3, multiply by the 2 in the denominator, then add that to 1, rewrite it as 7/2. Do the same thing with the second fraction so that you have 7/2 times 25/3. Multiply straight across, but don't cross-multiply. Then rewrite the fraction as a mixed number by dividing the numerator by the denominator. The quotient of the whole number part is the remainder, and the remainder of the new number is the fractional part. It's not really any wonder that fractions are one of the highest anxiety-causing math topics. But now this model allows me to see that 3.5 multiplied by 8 1/3 is just 4 parts. It's 3/8, 3/3, half of 8, and half of 1/3. It is the hope that eventually students will be able to do every multiplication problem ever, because they understand that in general, any sum can be multiplied by another sum according to this model. And each new challenge is an easy extension, rather than a new set of rules and tricks to memorize. I want to be clear that I am not opposed to traditional algorithms, shortcut methods, and formulas. I just don't think that teaching these methods will lead to greater understanding or encourage innovation and diversity of ideas. In fact, I'd like to leave you with 3 ideas that I believe will lead us on the path to greater mathematical innovation. First, embrace challenge. Each one of us is on a mathematical journey. It is easy to see someone further along on their journey and think, I'll never catch up. I may as well just stop here. Instead, we need to be saying, whoa, that seems cool, I can't wait to get there. We need to turn our own anxiety triggers into ignition keys, recognizing that the holes in our understanding are opportunities to grow and learn. We need to do this, you and I. If we want our children to achieve new heights of mathematical success, then we need to show them that difficulties are normal, frequent, and welcome. We need to show them by our own examples that the best things in life do not come easy. Second, throw away the answer key. We all have a tendency to fixate on the end and ignore the journey. In math, just like in life, it's normal to want to know, am I doing this right? You don't need to know the answer. Let me repeat that so you know how strongly I feel about it. You do not need to know the answer. In fact, giving away an answer too soon can rob someone of valuable learning experiences. If you're a parent, practice saying, wow, can you show me how you did that? If you are a teacher, practice saying, maybe. Does it make sense? Can you defend it to your neighbor and see what they think? Mathematics is full of unanswered questions. We need to show our children that we don't need to have an answer in order to learn. By taking emphasis off the end, we allow creativity and innovation to play a greater role on the journey. Ultimately, play. I do believe that when it all comes together, this is really the key. We are all familiar with math's left-brained persona. He is logical and practical, but also confident and cocky. Sometimes the way he calculates in his head or uses fancy vocabulary, sometimes this can make me feel inferior to his superior logical intellect. But do you know that math is a kinder and gentler, right-brained alter ego? She is creative, artistic, free-spirited, playful, stunningly beautiful, and a little bit elusive. She can sit with you for hours and make you feel like you have glimpsed the secrets of the universe. Invite math over to play. See what you've been missing. Parents, if you want to foster mathematical aptitude in your children, surround them with puzzles, blocks, games, and play with them. Encourage them to ask crazy questions just for fun and explore the answers together. How big is a million? What if 1 + 1 equals 3? Why does 1 and 0 make 10? Allow them to come up with their own answers and celebrate both the journey and the mistakes. Teachers, build some play into your classroom. Allow and even require students to explore, investigate, ask questions, reflect, and interact. And get in there yourself. Give yourself permission to ponder and be awed. Allow yourself to be sidetracked for a worthy purpose. Spend more time worrying about the questions and less time worrying about the answers. And let them see the twinkle in your eyes when you encounter a thing of beauty. By some lucky combination of accident and design, this was the mathematical environment that I grew up in. It shaped both the mathematician that I have become and my vision for a generation of future mathematicians. In this vision, mathematics is as much a discipline of self-expression as it is an exercise in reason. And success in this discipline is achievable by everyone and made richer by diversity and creativity. I invite you to share in the bounty of my experience and to come play with me. Thank you.